Welcome to Kempton Math. This is Algebra 2. We are in Unit 1. This is Lesson 7, the remainder theorem. So the remainder theorem is essentially a shortcut to find the remainder. So instead of using long division, you can find the remainder. So in order to find the remainder, you're going to plug in A into the expression. So how do you know what A is? Well, it always comes from whatever the binomial is. So if this was divided by x minus A, then you would plug in positive A. I always like to think of it as the opposite. When you get your remainder, if that remainder is equal to 0, then that binomial is a factor. So I'll go into what I mean by that. So for question 1, it says use long division to find the remainder when x squared plus 4x plus 3 is divided by x plus 3. So in this case, we're just going to go ahead and do a little bit of review to actually find our remainder. So x squared plus 4x plus 3, and we are dividing by x plus 3. Okay, so we need to figure out what multiplies to x that gets to x squared. So my first term is going to be x, because x times x is x squared. Now I also need to multiply that by the second term, so x times 3 is 3x. Now I subtract going down. Don't forget that that changes, so 4 minus 3 is just a positive 1, x. Drop this 3, and then we start it again. So what multiplies to x? That gives me x. Well, anything that is the same has to be multiplied by 1. So 1 times x is x. Don't forget that we also need to multiply that second term, so 1 times 3 is 3. And when I subtract going down, I have no remainder. So how can I find this remainder using the shortcut? Well, that's what's called the remainder theorem. So the remainder theorem says that we're plugging in a number. So what's that magic number that we're going to plug in? Well, it's always the opposite of the binomial. So if this is x plus 3, we're going to be substituting in -3. And where do you substitute in that -3? You're going to substitute into whatever I have here. X squared plus 4x plus 3. So now I'm going to substitute in -3 squared plus 4 times -3 plus 3. So let's see what we get when we have this. So I'm going to have my calculator here. When I plug in -3 into my calculator, it is equal to 0. And that matches the 0 that we got when I did it with long division. Okay, next question. So we are going to find the remainder using the remainder theorem. So in this case, we're just plugging in that magic number. So how do we know what that magic number is? So it's the opposite of the binomial that you're dividing by. So in this case, I'm going to be substituting in -1 into this polynomial. So I have -1 to the third power minus 3 times -1 squared plus 6x times -1 plus 8. And as you can see from our calculator, when I plugged in -1, I get a remainder of -2. Okay, so this next question is not only asking us what the remainder is, but they're asking us if x plus 3 is a factor of x squared plus 4x plus 3. So let's review what a factor is. So if I asked you, is 2 a factor of 6? The answer is yes, because 2 goes into 6 evenly, and as we can see, 3 times 2 is 6, and there's no remainder. But if I asked you, is 2 a factor of 7, the answer is no, because the closest number that multiplies to 7 is 3, but 3 times 2 is 6. So what you'll notice is that we actually get a remainder. So the only time that something can be a factor is if the remainder is equal to 0. Okay, so let's figure out if this is a factor. Well, we're going to take the shortcut. We're going to go ahead and find the remainder. So we always find the opposite. We always plug in the opposite, which in this case is -3. So let's go ahead and substitute that in. So -3 squared plus 4 times -3 plus 3. And if I'm correct, we actually had that for the first problem, and we already knew that the remainder was equal to 0. So my answer is yes, it's a factor. All right, moving on to the fourth and last question. Determine if x plus 2 is a factor of 3x squared plus 8x minus 4 using the remainder theorem, and then we're just going to add one more step. We're going to explain this. All right, so we have to find that magic number. So it's always going to be the opposite. So x plus 2, I'm going to be substituting in positive 2. All right, so I have 3 times 2 squared plus 8 times 2 minus 4. When I substituted in 2 into my calculator, as you can see, our remainder is 24. So now let's answer the question. Determine if x minus 2 is a factor. Well, it's not a factor because there was a remainder. So remember before how I said the only time something's a factor is if the remainder is equal to 0? Well, in this case, the remainder was not 0. So I actually have to use my words to explain that. So no, because the remainder was not 0. And there's a lot of different ways you can explain that. You could just say no because there was a remainder, or you could say the remainder was not 0, or you could just say no because it was not 0. Anything will get you 2 points on the regions. Thanks for tuning in. Have a good one.